Hey everyone, it's Mrs. Hoke. Today we're going to continue our solving three equations with three variables lessons. Today our focus is going to be on the elimination method. So sorry for a little bit low-tech notes today. We're having some technical difficulties, but I wanted to make sure that you had notes to view while I'm out. So here we are. So we've already covered how to solve three equations with three variables using technology, so using our calculators, whether it's your TI-84 graphing calculator or the Desmos matrix calculator. You have two methods to solve using technology. We also, in our previous class period, talked about solving using substitution. So like I said, today's notes are going to focus on using elimination. So we're going to use the skills that we talked about in our 2x2 elimination lessons, and we're going to apply that and extend that to solving three equations with three variables. So this is the same notes page that you were using the other day for substitution. We're just going to work on the elimination section. Step number one for elimination says that we're going to pick two equations and eliminate a variable by adding them together to make a new equation. I'm going to go ahead and label these equation 1, 2, and 3, just so as we talk through them, you know which equation that I'm referring to. So it doesn't matter which two equations we start with. We're going to eventually use all of them. I don't see any two that will eliminate automatically, meaning if I wanted to eliminate this 4x, one of my other equations would need to have a negative 4x as the coefficient, or a negative 4 as the coefficient. I don't see that. Same thing, if I wanted to eliminate this negative 5 in front of the z, I would need one of my other z coefficients to be a positive 5. So since we don't have anything that will automatically zero out, we're going to have to go ahead and create that by multiplying one or both equations to generate those zero pairs. So I'm going to go ahead and multiply this top equation by a negative 4 so that my negative 4x can eliminate with this positive 4x in the next equation. So remember to distribute that to all pieces, including your constant. So we get negative 4x minus 8y plus 20z equals positive 44. So we're going to cancel that out with equation number 2. I'm going to go ahead and bring that over. Okay, once I bring that over, we're going to add both equations together. And you'll see that negative 4x and positive 4x cancel out or zero out. Negative 8y and negative 3y makes negative 11y. 20z and 2z makes positive 22z. And, oops, I copied that down as a 44. That should be an 11. 44 and 11 makes 55. Sorry about that. Okay, so we're going to call this equation number 4. We've created a new equation that only has two variables by adding these two together to eliminate the x. So in step 2, it says we're going to pick two different equations but eliminate the same variable. So we're going to do that the same exact process to get down to two variables with two different equations. Okay, obviously only one of the equations is going to be different because I only have 3 to choose from. So I'm going to have to take equation number 3 and eliminate the same variable. So I'm going to have to eliminate the x in equation number 3. The only way I can eliminate a negative 3x is to have a positive 3x. So I'm actually going to, this time, pair up equation 1 and equation 3. So instead of multiplying this by a negative 4, we're now distributing a positive 3. So 3 times x is positive 3x. 3 times 2y is positive 6y. 3 times negative 5 is negative 15z. And 3 times negative 11 is negative 33. So I've multiplied equation 1 by 3. Now we're going to add these two together to create a new equation. So my x's zero out. 5y and 6y is 11y. 3z and negative 15z is negative 12z, and 8 and negative 33 is negative 25. So we're going to call this equation right here equation number 5. So now I've got 3 equations with 3 variables, but now I also have 2 equations that have 2 variables. So now we're down to 2 equations where we can use our process that we learned the other day with 2 variables to get those 2 variables to plug into the other equation. Okay, so if you look at step 3, it says take the 2 new equations, equation 4 and equation 5, and eliminate another variable. So if you look at these, you see a coefficient of negative 11 on the y and positive 11 on the y. These are going to eliminate without having to do any multiplication. So I'm going to just copy equation 5 up here. Positive 11y minus 12z equals negative 25. When I add these together, my y's cancel. I get 10z equals 30. And when I divide by 10, we find out that z has a value of positive 3. So our last step says we're going to substitute backwards in order to find our other variables. So we're going to come here, and you could substitute this into either equation 4 or 5, one of your 2 variable equations. And we're going to say 11y minus 12 times 3, 12 times z, equals negative 25. So 11y minus 36 equals negative 25. When I add 36 to both sides, I get 11y equals 11. So therefore, when I divide, y equals 1. And then my final step is going to go back up to our original 3 equations, equations 1, 2, and 3. Their very original version, meaning the original problem. So I can use any of these 3 equations to solve for x. I'm going to choose equation number 1 because x has a coefficient of 1. So I have x plus, we're using the original, 2y, 2 times 1, minus 5z, 5 times 3, equals negative 11. So this is x plus 2 minus 15 equals negative 11. 2 minus 15 is negative 13. X minus 13 equals negative 11. And when I add 13 to both sides, we find out that x equals positive 2. So you could write your ordered triple as 2, 1, 3. Next, I want to work through a couple of examples on your solving 3x3 systems of equation worksheet that you got last class when we were covering substitution. So these are the same problems where we were pulling from to do examples last time. So I'm going to do numbers 9 and 13. So if you wanted to try them on your own, you could, or if you want to just watch and take more notes, that's fine as well. Remember, there are a lot of different routes that we could go. So just because I choose to eliminate one variable does not mean that your way that you're doing it is any more right or wrong. As long as you're following valid algebraic steps, you should arrive at the same answer that I do. So in looking at problem number 9, I do notice that there is a positive 3z and a negative 3z. Once again, I'm going to label these equations 1, 2, and 3. So I see that equation 2 and equation 3, when I add those two together, can automatically get rid of my 3z's. So I'm going to go ahead and just add those together right here. I'm not going to even copy them over. So 4x and 4x makes 8x. 5y and negative 4y makes plus y. Negative 3z, positive 3z cancels out. Negative 19 and negative 22 makes negative 41. So I'm going to label this equation number 4. I've added 2 equations together and generated a 4th equation. Okay, our next step after we do that would be to use 2 different equations and eliminate the same variable. So I need to eliminate my x again. I have to use equation number 1 because we haven't touched that yet. And I notice that equation number 1 will also cancel with equation number 3. So my next set of equations are going to be equation 1 and equation 3. So I am going to go ahead and copy those two over just so that we can line up our variables and make sure that we're not making any mistakes with our addition. So there's equation 1, equation 3 is right here. So 4x and 4x makes 8x. 2y negative 4y makes negative 2y. My x's zero out. Negative 16 and negative 22 makes negative 38. Okay, so now I have a second equation that has two variables. I'm going to name this equation number 5. So now we need to take equations 4 and 5 and we need to eliminate a second variable. So I see that they both have 8x's, so we could multiply one of them by a negative 1 in order to get the x's to eliminate. And then I also see that they have a positive y and a negative 2y. So I could multiply that positive y, equation number 4, I can multiply everything by a 2 to get our y's to cancel out. It doesn't matter which way you do it. I'm going to go ahead and multiply this first equation by a negative 1. So when I do that, it's just going to change the signs on everything. So we get negative 8x. I'm writing it over here under equation 5 in anticipation of combining them. Negative 1 times y is negative y equals negative 1 times negative 41 is positive 41. So when I add these two things together, my x's zero out. Negative 2y and negative y is negative 3y. Negative 38, positive 41 is positive 3. So then I would divide both sides by negative 3, and we find out that y equals negative 1. Okay, of course, you could have typed this into your matrix prior to actually beginning to solve it and know exactly what answer you're working towards, because if we found the wrong y value, we wouldn't want to continue on and use that wrong y value to substitute in for the rest of the problems. So I actually did plug it in before we started. I put it in my matrix calculator, and I know that we're working towards the answer negative 5, negative 1, negative 2. So y equals negative 1 is a correct solution for that y. Okay, now we're going to work backwards plugging in to find our x and our z. So I'm going to take this back to equation number 4 and plug it in. 8x plus y, so plus negative 1, equals negative 41. Okay, plus a negative, that makes it subtraction. So the opposite of that would be to add to both sides. So we get 8x equals negative 40. When we divide by 8, we find out that x equals negative 5. Go up here to our ordered triple. Negative 5 is the correct value for x. So now we just need to solve for our z value. It's not going to matter which equation we use. We can use any of our original equations. I'm just going to pull equation number 3 down. So we have 4x, 4 times negative 5, minus 4y, 4 times negative 1, plus 3z equals negative 22. So if I multiply these out, I get negative 20 plus 4 plus 3z equals negative 22. Negative 20 plus 4 is negative 16. Plus 3z equals negative 22. If I add 16 to both sides, 16, we get 3z. I'm going to come over here since I have space. 3z equals negative 6. When we divide by 3, we find out that z equals negative 2. So that gives us our third correct value for our ordered triple. The second problem I want to do off of that practice page is problem number 13. So this one's going to involve a little bit more work because we're going to have to work a little bit harder to get some of the variables to cancel out like we need them to. So I'm going to start by writing the correct answer up there at the top so that we know what we're working towards. So for this one, we should get an ordered triple of 5, -6, -2. So we know what we're working towards. Step number 1 says that we need to take two equations and get a variable to eliminate. So it doesn't matter which variable we start with. We have a lot of options. I'm going to go ahead and just start with my x's. So I noticed that equation 3, and I'm going to just label these 1, 2, 3 so you know what I'm talking about. Equation 3 has a -2. Equation 1 has a +6. So I can get the x's to cancel out if I multiply this bottom one by a +3, because that's going to give me -6x, +12y, -12z, and then 26 times 3 is -78. I'm going to copy over equation number 1. So this blue equation over here is combining these first two. So I have 6x plus 6y plus 5z equals -16. When I add these two together, my x's zero out. I get 18y minus 7z equals -94. So that's going to be equation number 4. We've eliminated a variable and created a new equation. Okay, our next step says that we need to take two different equations, a different pair of equations, and we need to create a fifth equation. So I've already used the first and the third. That means that I need to eliminate my x in the second equation. And there's no way that I can get either one of the other equations to have a -5. So I'm going to have to multiply two different equations to cancel out. And it doesn't matter which ones, but I'm going to get this 5x and this 2x to cancel by getting them to be a 10 and a -10. So in order to get this equation in the middle, equation 2, to be a 10, I'm going to multiply it by a 2, which gives me 10x plus 8y minus 2z equals 6. So that's by distributing out this 2 to equation number 2. Equation number 3 to have a negative 10x is the coefficient, so we can cancel it. So instead of multiplying it by 3 like we did last time, we're going to multiply it by a 5. So 5 times -2x is -10x. 5 times 4y is +20y. 5 times -4z is -20z. And 5 times -26 is -130. So I'm going to add these two equations together. My x's zero out. 28y minus 22z equals -124. So that's going to be my equation number 5. So now that we've generated equation 4 and equation 5, we're going to use those two to eliminate a different variable. So you'll notice one has a coefficient of 28 on the y, the other has an 18. One has a coefficient of -22 on the z, the other one has a -7. So we're going to have to do some big time multiplication in order to create something that will cancel out. I'm going to go ahead and I'm going to work on my z's. So I'm going to multiply this equation right here by a 7. So that may or may not be creating a least common multiple with the 22 and the 7, but I know ultimately I'm going to get something that's going to cancel out. So if we have 7 times 28, that's going to give us 196y. 7 times -22 gives us -154z. And then 7 times -124 gives us -868. Okay, working with equation number 4, in order to get it to cancel with the z, I need it to become positive. So I'm actually going to multiply this whole entire thing by -22. So if I do -22 times 18, that's going to give me -396y. Notice I'm writing it below the one that we're anticipating to cancel with. If I do -22 times -7, we're going to get a positive 154z, which is exactly what we need to get it to cancel. And then I'm going to do negative 94 times negative 22, and that's going to get me a positive 2,068. So really large numbers, but you're going to see that it works out to something that's not so large. So I'm going to go ahead, 196 and negative 396 gives me negative 200y. My z's zero out, and then negative 868 positive 2,068 gives me a positive 1,200. So when I divide by negative 200 on both sides, we find out that y equals negative 6, which is exactly what we needed it to be. So some of our coefficients became really large, but it worked out to exactly what we thought it should be, or exactly what we knew it should be. So then we're going to work backwards plugging that in to find values for our other two variables. I'm going to plug this in up here to equation 4 to find my z. So I have 18 times negative 6 minus 7z equals negative 94. So if I do 18 times negative 6, I get negative 108 minus 7z equals negative 94. And then we're going to go ahead and add the 108 to both sides. Oops, 108. So negative 7z equals positive 14. Divide by negative 7. We find out that z equals negative 2. If we look up at our ordered triple, that's exactly what we need it to be. So I know y is negative 6, z is negative 2. I just need to plug into one of my original 3 equations up there in the black to find my x value. I'm going to plug it into the top one just because we have not messed with that one as much, and it's easier to just see what the original equation was. Any of the black equations up here that we started with would be fine. So I'm going to plug in. I have 6x plus 6y, so plus 6 times negative 6, plus 5z, so plus 5 times negative 2, equals negative 16. So if I were to multiply those out, you would get 6x minus 46 equals negative 16, because this is negative 36 and negative 10. When I add 46 to both sides, we get 6x equals 30, and dividing by 6, we find out that x equals 5. Right here, my ordered triple, x is 5. So my final answer here would be 5, negative 6, negative 2.